have a revision on the single phase transformer on the last bit of the topic, which is called the voltage regulations. Now the formula for voltage regulation of transformer is V1 full load minus V1 rated divided by V1 rated times 100%, or if you work on the secondary, it will be the second V2 full load minus V2 rated divided by V2 rated times 100%. Now what's the meaning? The meaning is, if I were to say a transformer, if you recall our transformer, this is an ideal transformer, right? If I say this is a 220 volt to 440 volt transformer, that means to say if I have if I supply 220 volt, I would be able to get 220 volt here, and the voltage here is become 440, and here is 440. So that is ideal situation. But a practical transformer is unlikely to be like that. A practical transformer, there are parameters. Alright, remember R1, X1, R2, X2, right? And then you have the core loss resistance and the magnetizing reactance. Yeah? So if I were to really put 220 volt, there won't be a voltage drop here. Do you think this voltage should be 220? It may not be, because there's Kirchhoff's voltage law says this minus this must be equal to this, right? So let me just fabricate a value. Let's say it becomes 217 volts. Okay, and the voltage therefore induced, because the ratio is times 2, so I will get 434 volts. Correct? 434 volts. And again, there's a voltage drop here, so eventually I may not get 434, maybe it's 430. So you can see, based on a practical transformer, your rating is 220 and 440. If you were to put 220, eventually you don't get 440 because of the voltage drop, right? So it becomes 430. So in order for this to be improved, I want it to be 440. If I want this to be 440, here must be more, right? If here needs to be more, here needs to be more. If here needs to be more, here needs to be more. And just like in the practical, you therefore increase the voltage. You increase the voltage until here register 440. So imagine if you were to have compensate the voltage, right? You have to adjust it up to 227 volt in order to get 440 volt, right? In order to get 440 volt, right? In other words, 227. So let's say now you get 220. So the voltage regulation therefore say this is the full load voltage 227 minus 220 divided by 220 times 100%. That's the meaning. That means to say how much must you compensate to make sure that the voltage appear as what you wanted. Got it? So that's called voltage regulation. A bit messy, but let me try and explain one more time. Ideal transformer. If I supply 220, I'll get 220 here. And voltage becomes 440, there's no voltage drop. But a practical transformer, you have voltage drop. Through R1, X1, R2, and X2. Remember the winding resistance, the leakage reactance, core loss resistance, magnetizing reactance, right? So if I were to say, in order to maintain here as 440, if I want to maintain here as 440, the voltage here definitely must be more than 440, right? So let me say that is 444. Okay, and then after taking a loss of 4 volt, become 440. Just treat like normal mathematics without confusing with complex number. If here is 444, here is actually 222. Am I right? 222. And there is a voltage drop here. Why 222? Because you have a 2. The ratio is 1 to 2. So there is a voltage drop. So if here is 222 and then there is a drop here, right? Then what is this voltage here? Your voltage here actually has to be, let's say, is 5 volt. Then here must be 227. Am I right? 227 minus 5 give you 222. Right? So that is what voltage regulation say. Voltage regulation say you must. So voltage regulation is you must increase this voltage to 227 versus the original, which is 220. So the smaller the value, the better is our transformer. Okay, so that's voltage regulation. Now this is for practical. This is for practical. Now in the tutorial questions, the challenge is actually to find out this value. This value is given in the question. Let's say it's 220 versus 4400 volt. You know that the V1 rated is 220. Correct? So the challenge is to find this value. And to find this value, you have to use your EChem knowledge using complex number by Kirchhoff's voltage law. Okay, let me illustrate. Okay, voltage regulation. Let me pick one question on voltage regulation. Okay, alright. I say that this is a 10 kVA transformer and 60 Hz, 4800, 240 volt transformer, right? And you are given the REHV value, you are given the XEHV value. Okay, and alright. So part A say find the voltage regulation if the load is at unity power factor. Okay, at unity power factor at full load. Okay, so our method would be voltage regulation is equal to V1 full load minus V1 rated divided by V1 rated times 100%. Okay, now who is my V1? I make it as a step down. Yeah, so this is my V1, 4800. So this is 4800. So the question now is for me to find V1 full load. Okay, now V1 full load, if you were to use your transformer, right, so this is my high voltage and this is my low voltage. Alright, excuse me, Sean. Yes, it's okay. Sean, you can come over in half an hour's time. Okay? Okay, bye. Yes. Okay, bye. So we will go back to here. So here is my V1 full load, right? So this is my REHV and XEHV. Why do I call it HV? Because it's on high voltage side. Remember the equivalent resistor that's being referred to here. Okay? So here will be my V1 rated. Okay, and here is your high voltage current or low voltage current. Should be high voltage current, right? Okay, and then the theta. Remember the theta? Why minus? Because it's an inductive circuit. So we actually have to write a Kirchhoff's voltage law equation for the primary circuit. So we say V1 full load is equal to I high voltage minus theta bracket REHV plus J XEHV, okay, plus V1 rated 0 degree. We make this as a reference 0 degree. Here is 0 degree, so the current here is lagging behind the voltage. Inductive circuit current lags voltage. Alright, I know the value. Question give me these two values. I know V1 rated also, because V1 rated is 4800, right? Now it is at unity power factor. From your EChem, you know that at unity power factor IHV is 0 degree, right? So this plus this plus 4800, 0 degree. Okay? No. So it's only this one that we do not know. How do we calculate current? Okay? Remember our basic apparent power, S equal to V times I. So my high voltage current is equal to S divided by high voltage. Right? So it's 10 kVA divided by 4800. Get it? So with this, I substitute into here, I get an answer. Okay? With this answer, I substitute into my voltage regulation, I get the answer. Right? So that's part A. Alright, part B. Part B, the question is instead of unity factor, it is not a unity factor now. It operates at 0.8 power factor lagging. Alright, it is operate at 0.8 lagging. Your mathematics still the same. Now the theta must change, right? Yes? Let's try. V1 full load is equal to I1 and minus theta REHV plus J XEHV plus V1 rated 0 degree. Who is my 1? 1 is my high voltage side, right? Yeah, so that is equal to my apparent power S divided by VHV. That's how I get my current, remember? And theta will be minus cosine inverse 0.8. REHV plus JXEHV, I'm given in the question, these two values, plus V1 rated, which is 4800. Right? So I perform my mathematics using complex number, I get an answer. For example, if the answer is 48154, okay? An example, okay? If it's 48154, then my voltage regulation is therefore 4815 minus 4800 divided by 4800 times 100%. Got it? Yeah, that's all for voltage regulation.